Hello, boys and girls. We have a new science lesson today, continuing to talk about the sun as the center of our solar system, some of the qualities of the sun, as well as talking about gravity. So I've got a science source book that I'm going to be reading to you from, and what your third grader needs to know. I know that there are at least a couple of people who have each of these, so I'll give you page numbers in case you want to follow along. Okay, so and you also have another video to watch that's really informative about some of the specific details of the sun and the planets that we're going to get into, all of the planets in our solar system, starting on Wednesday. Okay. Now, the sun is an average-sized star in the center of our solar system. This is from page 226 in the science source book. Everything in the solar system revolves around the sun. Everything is kept in orbit by the pull of the sun's gravity. The sun rotates on its axis. The sun completes one rotation in 25 days. It takes 25 days. We'll remember one rotation on its axis for us on Earth is 24 hours. Now, gravity is a force that pulls objects toward one another. All objects produce a force of gravity. Now, I know this is somewhat review, so for those of you who already know, what has a stronger force of gravity? Less mass or more mass? A greater mass has a stronger pull of gravity. For example, all of the planets that revolve around the sun, that orbit the sun, are smaller in mass than the sun. And so that's why we are pulled by its gravity and pulled toward it. We're not moving the sun toward us. The bigger the mass, the more the pull of gravity. Now, the sun has much more mass than Earth, so the sun's gravity is much greater than Earth's gravity. It says here with a picture of some astronauts, the force of Earth's gravity tends to pull objects toward Earth. At the same time, the outward movement of an object in orbit tends to move it away from Earth. When these forces balance, the object doesn't move either toward or away from Earth. It just floats in space. So, like if these astronauts are in space between planets, they are just floating and weightless technically, but weight is different than mass. Their mass does not change. What makes up their bodies, that does not change. It's just that the gravitational pull evens out. Now, as the distance between objects increases, the force of gravity between them decreases. Again, as the distance between the objects increase, the force of gravity between them decreases. So there's less gravitational pull as you get further and further away, which is why Mercury has a very unusual orbit. It gets really close to the sun and speeds up when it's close to the sun. And then when it moves away from the sun, it slows down, speeds up, slows down, speeds up, slows down. So as you're getting further and further away, there's less of a gravitational pull. The sun's gravity keeps the planets and other objects in the solar system in orbit around the sun. An orbit is the path of one object around another object. If it were not for the sun's gravity, planets and other objects in the solar system would speed off into other parts of the universe. The gravity of a planet keeps its moons in orbit too. And since Earth is larger than the moon, we have a greater mass than the moon, we keep the moon in orbit because our gravitational force is stronger. So we draw the moon toward us. It's not that we move toward the moon. Okay, that is all for the science source book, but I am going to read a little bit from also what your third grader needs to know. And we are going to read from page... starting on page 322. Yeah. Okay. Now, when we say solar system, what does that mean? Well, solar comes from Latin. Sol means sun. So a solar system is a system of things around the sun. And as we've talked about, the sun is a star, just a medium-sized star, not the largest one in the universe by far. I know we spent time watching that cool video of the comparison between all of the planets getting progressively larger, and then the stars and some galaxies that get larger and larger. So solar system is just a group of things that interact with the sun specifically. Hundreds of years ago, people believed that the sun, stars, and all other planets circled around the Earth. They didn't know any better. The Earth is what they were obviously most familiar with, and they thought everything else was in orbit around us. Some Greek astronomers guessed that Earth circled the sun instead. It was Greek astronomers who thought that, but their ideas didn't take hold. Then, in the 1500s, there was a Polish astronomer named Nicholas Copernicus who argued that it was the sun, not the Earth, that was the center of our solar system. Not many people believed Copernicus during his lifetime, though. Today, no one would argue with him, though. And there is another part of the book that talks more about Copernicus. If we have time, we'll read more about him and his discoveries. Now, the sun is a star like other stars you see at night. The sun looks bigger and brighter than other stars. Do you remember what reason is that? Even though it's not necessarily bigger, it's closer to us. That's the only reason. Now, even though it's the closest star, the sun is still 93 million miles from the Earth. Now, light travels very fast. When you turn on a lamp, think how fast its light reaches your eyes. It seems instantaneous. For the sun's light to travel 93 million miles to reach us here on Earth, it takes about 8 minutes. Now, how big is Earth compared to the sun? Once again, we watched a cool video to show the progression of us and other planets compared to the size of the sun. I think that visual is helpful. But also, you can imagine if the sun was a basketball, Earth would be like an orange seed inside of it. Or think of just a little seed in general next to a basketball. That's the size comparison. Now, like other stars, the sun is a giant ball of churning, glowing, exploding gases. On a very hot day on Earth, the temperature might reach about 100 degrees Fahrenheit or possibly a little more. The surface of the sun, though, can reach 10,000 degrees Fahrenheit. And astronomers believe that the deep core inside the sun may be hot as 27 million degrees. And it's not even the hottest star. Now, the natural world depends upon the energy that comes from the sun. Without the light and heat we get from the sun, life simply wouldn't exist. But don't worry, the sun is not going to go anywhere. Even though over the course of millions of years, stars do explode, they stop existing anymore. But that would not happen for billions of years. It will still be billions of years from now that would ever happen. Now, around the sun travel the 9 planets, which are Mercury, in 8 plus a dwarf planet. Mercury, Venus, Earth, Mars. You remember the others? Jupiter, Saturn, Uranus, Neptune, and Pluto, which is considered a dwarf planet. The word planet comes from an old Greek word which means wanderer. But planets do not wander around the solar system. They travel around the sun in an orbit. That's its path. Here is a picture to show Earth in orbit. Orbit is the path around the sun. Rotation on a planet's axis is just its turn. A little spin. You could think of this as a spin versus this is a full rotation or a path all the way around the sun. As the planets orbit or go around the sun, that means they spin around like a top. So they're rotating on their axis as they're also orbiting. Earth both orbits the sun and it rotates. We say that the Earth rotates around an axis which is an imaginary pole running through the center. And it's on a tilt, so it's not directly north and south like you might imagine, okay? It's on a tilt, but it's this imaginary line running between the North Pole and the South Pole, those magnetic poles at either end. Now, if you were to spend a day keeping track of the position of the sun in the sky, it might appear as though the sun is moving. Get up early some morning and notice where you see the sun. A few hours later, Earth has rotated so that it looks as though the sun has moved to a different place in the sky. You might notice at home sometimes that at different times of the day, one part of your house would be sunnier than the other, and then it changes at another hour of the day. When evening comes, notice where the sun sets. It always sets in the west. Let me get my direction straight. This way on the map. It always sets in the west and rises in the east. We talk about the sun rising and setting because that's what the sun appears to do to us. The way that we're seeing it from our specific place. If the sun, actually there's a glare right there from the light in my ceiling. So imagine that's the sun. We're getting a lot of sunlight in the middle of the day. And then as we get farther and farther away, that's where the sun is, and we're stopping seeing any sunlight. We're seeing it start to set according to our place on the earth. It only looks that way though because it's Earth moving, not the sun actually moving. It's Earth moving. It takes a day for Earth to make one complete spin around its axis, which for us is 24 hours. It's not the same for every planet. When the place where you live is turned toward the sun, it's daytime for us, while it's nighttime for the people on the opposite side of the Earth. As Earth continues to rotate, the place where you live turns away from the sun, and it becomes nighttime for us. So 24 hours to make that complete rotation. That's why we have different time zones as well. And how long does it take for Earth to orbit completely? 365 and 1/4 day. That's why we have a leap year, because it is just a fraction of a day. And since it would not be practical to ever have a fraction of a day, the Romans actually decided on that leap year so that, actually, I'm trying to think. I think it was the Romans since they were coming up with the calendar. So it's 1/4 of a day. That 1/4 of a day ends up being just one extra day every 4 years, and we call that a leap year. One last little section here says, the Earth doesn't stand straight up and down on its axis as it spins. It's tilted slightly, and this tilt actually causes different seasons. When we have summer, our part of the Earth is tilting toward the sun, getting more sunlight. So when it's tilted toward the sun, getting more sunlight than down here, notice. That's our summer. The tilt means that sunlight is shining more directly on us, providing us more warm weather. When we have winter, our part of Earth is tilting away from the sun. So that's when we have winter. As you can see here, there's northern spring, southern fall, northern winter, southern summer, northern fall, getting more, northern spring, southern spring, and then northern summer, southern winter. So depending on the tilt, whichever one is getting more sunlight is going to be the one that's in summer or close to the summer months. Okay, that is all for today, other than that extra little video that you can watch as well, which I think is really informative. I also have a whole folder on Bright Thinker of other astronomy videos that I'll continue adding to through the course of this unit. Hope that you all enjoy, and I will see you later. Bye.